Okay, we're ready to begin video 1 for Civil Engineering 221. This course is called Engineering Mechanics and it's called Statics. And basically what this is it's a course to learn how to apply Newtonian mechanics to engineering problems involving forces and rigid bodies. And if you're dealing with Newtonian mechanics in general, we can also talk about dynamics, but this class is strictly associated with statics. But anyway, let's define what Newtonian mechanics is. And according to our books, they say that Newtonian mechanics is that science which describes and predicts the conditions of rest or motion of bodies under the action of forces. So what we're talking about here is the world is full of bodies, and the bodies come in contact. There's gravitational forces, there's magnetic forces, there's other type of forces that were involved in what we're trying to figure out based on Newtonian mechanics is how these bodies and forces interact. Now, I understand that you have been considering Newtonian mechanics for quite some time. I think maybe the very early junior high level, maybe they start to talk about it slightly, and then I know you've done it in high school, and then I also know that you've taken physics, or you wouldn't be in this class. The problem with all those is that many times the people that teach those courses don't exactly say things right, and I'm not saying they say things wrong, but I'm just saying they don't exactly say it right. So a student coming out of those classes often has a skewed view of what we're really talking about. And so like you come into this class and you think, okay, here he goes. He's going to do an introduction to this material. We already know this. We've seen this since junior high. So let's go to sleep or go to the chicken, and then we'll show up for like lecture 3 or 4. What I'm telling you is this lecture and the next lecture are perhaps the most important lectures in the class if you really want to have a deep understanding of this issue. And a deep understanding of Newtonian mechanics is required if you're going to be successful as an engineer. Now, I'm fully aware that you get tired of going to classes where your professor says, this is the most important class in the world, and so you should study my stuff first and do all the homework and do everything exactly like I tell you because this is the most important class. And I know you get tired of people saying that, but this class really is the most important class you will ever take. So I'm not just saying that, that's a fact. If you have this class and then you have the follow-on mechanics class and then perhaps the structural analysis class, you'll be well equipped to deal with most structural engineering type problems. If you don't understand this stuff, you will never understand what you're doing. So this is very important. So I want you to try to clear your brain, take a deep breath, and let's talk about these fundamentals because they really are very straightforward, but you have to have them straight. To begin with, if you're talking about Newtonian mechanics, we can talk about rigid bodies, or we can talk about deformable bodies, or we can talk about fluids. Now, a rigid body, if I had an object that maybe was a rectangle like that, and I said I displaced that rectangle to a new position, so somehow I moved that rectangle from this position to this position, but all the spatial relationships of all the points on this rectangle remain the same over here. Everything's the same except I just slid it over there, but the actual shape of it didn't change. Or maybe what I did was I rotated it up like this. Okay, so that the shape doesn't change, then this is said to be a rigid object. Now, most important thing you know about rigid objects would be that there are no rigid objects. Okay, all I'm telling you is that all objects, when they're acted upon by forces, there would be deformations associated with that. And so there are no such things as rigid bodies, but there are many things that we can consider to be rigid bodies without introducing very much error. And so that's the kind of things we're going to be talking about in this class, is things that you can consider to be a rigid body when in fact it may not be a rigid body, but the difference is so slight it doesn't matter. So rigid bodies is our assumption. When you go to 220 or 305, which is the mechanics of solids class, I guess that's CVEN 305, then we will start to talk about things that deform. And as I told you, all things deform. It's just a question of how much. But once we go into that 3V or CVEN 305 class, we'll come back and we'll find out about deformable bodies, and we'll take this material that we've learned here, assuming rigid, and bring it into the context of what we're going to call small displacement. So you got rigid, and then you got things that slightly deform, and then you've got things that deform a lot. It's kind of like classes of things we're looking at. But this class, there's no deformation. 305, there's a small amount of deformation. And then usually at an undergraduate level, we don't get into things that deform a lot. Now, our other option is fluids. That's like water flowing in a pipe or hydraulic fluid flowing in something. And we have a basic class here that we teach that involves fundamental mechanics of fluids. But to do the things in this class, you have to understand the things that I'm about to teach you. To do the things in this class, you have to understand the things that I'm about to teach you. And then we follow on with a structural analysis class, which right now we call 345. And in order to do that class, it starts back with this rigid body, and then you have to understand this, and then you can understand the 345. So what I'm talking to you about here is incredibly fundamental material, which you must master before you can be successful as an engineer. So pay close attention to what we're talking about here.